Welcome to Sandy Cybersecurity. Hi there. I'm Sandy, and I created this channel to make the world of cybersecurity simple, informative, and accessible for everyone, from beginners to professionals. Whether you're curious about securing your personal devices, understanding the latest cyber threats, or even pursuing a career in cybersecurity, you've come to the right place. Analyzing traffic, facilitating difficulties, and fixing connection problems are crucial in complicated networks of any size, but especially in big, dynamic networks. Network scanning involves finding interaction assets that are alive or have a heartbeat, and then collecting as much critical information as can be gathered about those assets. Network scanning can be divided into 4 stages. Network mapping, open ports, services running, operating systems. Active probing is a network mapping technique that involves transmitting specifically designed packets to target devices or IP addresses within a network to obtain replies. These replies disclose details on the network's architecture, devices, open ports, services, and settings. Tools such as Nmap utilize active probing to discover and map assets through response analysis, enabling users to get a comprehensive picture of the network. Nmap sends both TCP and UDP packets to a targeted machine. These are called probe packets. A probe packet is a packet utilized in an active tool to gather data on an interest network segment. And data is gathered returning that information to Nmap after sending those probe packets hopping from node to node and asset to asset. In network mapping using Nmap, probe packets are sent to devices, nodes, across a network. These packets travel from one node to another, collecting information about each device they encounter. When a device responds, it provides data such as open ports, services, operating systems, or network configurations. Nmap analyzes these responses to map the network structure and identify the connected assets, making it an effective tool for network discovery and security assessments. Scanning 65,536 ports on each computer inside your ecosystem would require an excessively prolonged duration and is largely useless. Occasionally, you may hear someone refer to a host discovery scan as a ping scan. In Nmap, you could choose to skip the ping itself and use other targeted methods to find the active hosts on your network. As we all know, network environments all are different, therefore host discovery needs are going to vary different. And all the hosts on your network do different things, and when it comes to setting priorities, not all assets are equally important. Some assets are mission critical, while others are utilized rarely and hold lesser significance. By default, Nmap starts its process by launching host discovery. By default, Nmap will send an ICMP echo request, ICMP timestamp request, A simple Nmap scan can be changed to fit your needs by adding different choices. You will definitely want to be using administrator credentials to execute these commands to achieve the best results. As an example, Address Resolution Protocol, ARP, is turned on when you use administrator access to scan networks. ARP is a protocol for mapping an IP address to a physical address on a host called a Media Access Control (MAC) address. The table that gets created during an ARP request is called the ARP cache and matches a host's network address with its physical address. Updating ARP cache. Both PCS update their ARP caches. PC1 adds an entry linking IP1.1.1.2 to MAC0x4A56. PC2 adds an entry linking IP1.1.1.1 to MAC 0x4A55. Cache usage. For future communication, devices refer to their ARP cache instead of broadcasting a new request, speeding up data transfer and reducing network congestion. This cache is temporary, and entries may expire after some time to ensure the mapping stays accurate. If an entry expires, the ARP process repeats when needed. How to install Nmap. To set up Nmap on Windows, do the following. Step 1. Use any online browser to go to the official page at https://nmap.org/download HTML and then click on Nmap 7.95 setup.exe. Getting this working file will begin soon. It won't take long. 32.4 megabytes is a small file size. Step 2. Now check for the executable file in downloads in your system and run it. Step 3. It will prompt confirmation to make changes to your system. Click on Yes. Step 4. The next screen will be of license agreement. Click on I agree. Step 5. Next screen is of choosing components. All components are already marked, so don't change anything, just click on the Next button. Step 6. In this step, we choose the installation location of Nmap. By default, it uses the C drive, but you can change it into another drive that will have sufficient memory space for installation. It requires 84.3 megabytes of memory space. Step 7. Step 8. NPCAP installation will also occur with it. The screen of license agreement will appear. Click on I agree. Step 9. Next screen is of installation options. Don't change anything and click on the Install button. Step 11. After completion of installation, click on the Next button. Step 12. Click on the Finish button to finish the installation of NPCAP. Step 13. After completion of the installation of Nmap, click on Next button. Step 14. Screen for creating shortcut will appear. Click on Next button. Step 15. Click on the Finish button to finish the installation. Step 16. Nmap is successfully installed on the system and an icon is created on the desktop. Step 17. Run the software and see the interface. So this is how you have successfully installed Nmap on your Windows system. I hope you found today's topic insightful. Thank you so much for watching. If you enjoyed the content, please like the video and subscribe to the channel for more updates on cybersecurity. Your support means a lot. Signing off, yours Sandy.